us tonight as we're going to be giving you several celestial views from the Georgia Tech Observatory. Thank you again for joining us. So tonight, people assisting us are Megan Birch from the Georgia Tech Research Institute is operating the telescope. We have several objects we're going to be looking at. And we have John Wallum from the College of Sciences, who's handling all of the telecommunications and IT. And I'm Jim Sowell, the director of the Observatory, School of Physics of Georgia Tech. So what we have planned for you tonight is at least 4 great objects, and we're starting on Mars because there are clouds over the Moon, Jupiter, and Saturn, but they're moving away, and so we will eventually get to that. I think we'll be broadcasting for 30 to 40 minutes or so. I also want to say hi to my Georgia Tech students who are going to be getting extra credit. I'll give you the directions on what you have to do in a few minutes. Okay, but we're ready to look at Mars. We are looking at Mars. And first off, you can see the disk, and you can see some dark regions on Mars. Mars and the Earth have orbits that about every 2 years Mars gets close to us, and that's actually why NASA is sending spacecraft about every 2 years to the planet. This closest approach, which is called perigee, is one of the better approaches. It takes about 15 years to cycle through being very close to being far away. Very close was about 2 cycles ago, and we were at perigee last week. So this is why Mars looks so nice, and it's good to get the views this week and next, because when Mars returns to its closest in 2 years, it won't be quite as good. In fact, this is probably the best view for the next 10 years or so. Now, as you look at Mars, we do not see the canals that Schiaparelli and Percival Lowell had suggested, but you are seeing some gray against the orange background, and that's real surface features. Mars has global dust storms which get picked up and can cover the entire surface, and then the dust settles down. And when it does, some regions are covered now with dust, and so they don't look as gray, and other regions get exposed. So every 2 years, the surface does look a little different. But this is an actual, you really are seeing the surface of Mars. Let's see a few other details about Mars. It is the 4th planet from the Sun. Its rotation rate's just a little bit longer than the Earth's, and it has a tilt about the same as the Earth. So it goes through 4 seasons of winter, summer, August, and spring. But because its atmosphere is so thin, it doesn't have the kind of weather that we have. There's very little difference other than the polar caps grow in size or shrink, and maybe a little bit of frost appears. If you walk outside after tonight or tomorrow night, Mars is the bright orange object toward the east. So if you don't know your compass directions, let's work on that. But just remember where the sun set. It's in the exact opposite direction from that. And so it's about 30 degrees up right now. How do you guys feel? So we've zoomed in on Mars. The wiggling on the sides shows that we are in the Earth's atmosphere. It is a little windy today. It's not a Hubble picture, but you can really see a disk. And I must say, this week is about the best I've ever seen Mars during my entire career. Normally I've made the mistake of looking at Mars when it's much further away and just a small orange dot. I think you can really make out structure in the gray. Should we stay on this for maybe 30 more seconds, and then we'll get ready to go to the next object? How am I doing? Let me add, the telescope that we're using is the 2nd largest one at the observatory. It's a Celestron 11-inch diameter, and we're using a technique known as eyepiece projection, which is we're able to get a higher magnification, which means a smaller field of view. So you can see that Mars is really filling our screen. We're going to move to Saturn in a minute, and we hope that the pointing of the telescope is superb because our field of view is so small. If we cannot find Saturn very quickly, then we'll go to the Moon. Now, if you want to go see these objects, tonight is a fantastic night to walk outside because you see the moon. It's a half moon. To the upper left of the moon is Saturn. To the upper right is Jupiter. It's making a beautiful equilateral triangle tonight, and I cannot tell you when that will happen again. So do enjoy that, but you can wait until we're finished. All right, so I hope everyone has enjoyed looking at Mars. It wasn't even on the schedule, and I consider it, of the 4 objects we're going to look at tonight, number 4. So all these other objects are going to look great, and Saturn is out from behind the clouds. So we're going to move the telescope. Thank you. So we're heading towards Saturn. The telescope is slewing, and Megan is getting it centered up. By the way, if you have any questions and you're not one of my students, again, you can go to the website, which just Google astronomy and Georgia Tech, and you will see my email link there. It's jim.sowell@physics.gottech.edu, and please send me a note, or certainly contact me if you have any questions at any point. Also, there is a link that says Observatory Events, and there you can join our email list. I try to send out a message a few days ahead of time. It depends on how the weather's looking, and just a reminder of what's coming up. But there's also a poster that lists the next public nights, and the public nights are always on Thursdays, and we always try to do it when the moon is at first quarter, because that is the best time to view the moon. So we're still working on trying to get Saturn into the eyepiece, and unfortunately a few clouds are coming back, but we can see it. So I anticipate that we'll have it in just a minute. So give us one more minute and keep the emails and such coming. Or, take a second and run outside right now and look up. This is a beautiful view. We're enjoying sitting out. October is certainly one of our nicest months. We're sitting out on the roof in short sleeves and just enjoying such a great view. I see I'm getting lots of emails, so I'm glad the students are watching. And this is actually especially important for my solar system class. We started talking about Mars yesterday. I'm glad they're getting to see it. And in a couple of weeks, we'll be doing Saturn and Jupiter. We've already talked about the moon. I mentioned that we always have our public nights when the moon is a half moon. Most people think that we should be doing it when it's a full moon. The orientation of the sun, earth, and moon when it's at first quarter makes a right triangle, and that way light that's hitting the surface of the moon is coming at an angle, and it will cast shadows, so we can really see the ruggedness of the craters and the mountains. When the moon is full, we don't get the shadows, and it's hard actually to see craters. You can see the darker maria, you can see some brightness contrast, but the moon really does look better at this phase, either a few days before or a few days after. Okay, so again, we're very, very close to Saturn, so just give us a second. Again, that's the trade-off that we have, this higher magnification. Oh, I also wanted to give a shout out and a thank you. The First Center, the Performing Arts Theater here on the Georgia Tech campus, is open tonight, and they're showing the images that we're sending, and I hope that they're having a good turnout. I suggest that my students go there, and please keep a thought about the First Center when we're able to really start having performances again. I've seen quite a few there, and they are one of those jewels on the campus that few people know about. They really have a great series of shows, and we're looking forward to being able to have them do what they're designed to do. And again, I'm very thankful that they approached us about doing this, and hopefully we'll be able to do some more in the future. So we're hoping that on their big screen right now, in just a second, they're going to be wowed by the view. So I think we're getting extremely close. So we're focusing. Is that what we're doing? All right. So they're focusing. That means they've got it. And we're going to get to see it in a few seconds. Always a few seconds longer than what I'm hoping for. But we also want to give you the very best. So when you look at Saturn, you will certainly see the rings. Now, Saturn is 9 times larger than the Earth, and rings, which are such an impressive feature, they look like they're solid washers, but they are not. They are made out of billions of tiny little BBs covered with ice. And there's the view. Are they seeing it, John? All right. Thank you, too. Okay. So, not only is it great that Saturn is out, and it's out in no longer the summer, but the autumn, because of the orbit of Saturn, which is about 30 years with respect to the orbit of the Earth, our orbits are slightly tilted. How are we doing? Am I live? Okay. So, our orbits are slightly tilted, so sometimes we see Saturn really well like this, and then other times the rings are edge on and disappear, and then we see the beautiful view again. This is about the greatest tilt in its orbit that we will have, so we are also having a great view of Saturn this year. As I was mentioning about the rings, they look like they're solid, but they're made out of billions of tiny particles about the size of BBs covered with ice. But what I think is so impressive is that the thickness of the rings is only about 10 yards. That it's very wide, but very, very thin. Now, you don't want to send a spacecraft through the rings. That would get destroyed. And I'm looking at the computer screen and seeing the beautiful view, but I'm also looking up at the sky and now seeing the clouds have gone away, and it's this beautiful view. In fact, I hope somebody takes a picture of these. So a few other facts about Saturn. Again, it's 9 times the diameter of the Earth, and it's about 95 times the mass of the Earth. And so we're seeing 2 views. We've zoomed in, and you can see the effect of the atmosphere, but you can see I can barely make out a dark stripe on the center of Saturn near the equator, and that's actually a shadow from the rings falling on the surface. The Saturn rotates in about 10 hours, and it's beautiful with those rings. Hope you like it. Now, Saturn also has several moons, including a very large one, and I'm trying to see if we can see it. But I think what's happening is, in order to make a longer exposure to bring out the moons, then Saturn would become burned out. So we're just going to leave it with the view of Saturn. So we're going to leave it here for a few minutes and enjoy, because again, this is fantastic to see Saturn with the open rings. I can remember the first time I saw Saturn through a small telescope. I was 17, and the rings were for real, and I felt good for 3 days that I had really seen it. So you're looking about, as far as time goes, you're looking an hour into the past. With Saturn, it's taking the light about an hour to get from the planet to us. Comments, questions? Sorry? Yeah, I think we'll stay here for a few minutes so you can enjoy this. Now, if you have a pair of binoculars, you will be able to see the moons around Jupiter, which we might try to do next, and certainly the craters on the moon. But unfortunately, a pair of binoculars, you will not be able to make out the rings of Saturn. You do have to have a magnification of about 50 times. And Galileo, with his telescope, he only had a magnification of about 10. So when he looked at Saturn, he could not see the rings, but he could tell that it wasn't spherical, that it was elongated. And he referred to Saturn as having ears. So we're very fortunate that with our optics and just a nice pair of binoculars, you can see some objects better than Galileo, but for a few things you do need a telescope, and I'm glad that we're able to bring you the views tonight. Again, if you have any questions, send me an email. I will try to get back to you. Probably won't be tonight, but I'll try to get back to you soon too. Also, if you're really enjoying this, it is going to our YouTube channel, and so it will be posted probably on Friday or Monday-ish. And you see that we have 2 other previous public nights. On one of those, we saw Venus, and both those were back in May. Venus is a morning object right now, and it's going to be half a year before we can see it again. So, we're doing fine? So, any comments? Anything? About 30 more seconds, let's say. And then, you feel confident in going to Jupiter? Yeah. Okay. So, yeah, we'll go to Jupiter. The moon will be the easiest, being so much bigger. When you go outside to look at these objects, hopefully tonight, notice that Jupiter and Saturn, and if you look way over to your left to Mars, these are all on one arc, and the moon's not too far off of it. This is the ecliptic path. All of the planets, including the Earth, are in this same plane, and so there is this band in the sky that the sun follows, path on the sky, and the planets are very, very close to that since we're all in the same disk. But this is a great visual to actually see that. Also, do enjoy looking at the phase of the moon. Tomorrow night, the moon's going to be we'll have passed these 2. It'll be to the left. It'll be the leftmost of these 3. Last night, it was the rightmost of these. So if you want to enjoy this view, and I would, go get a snapshot if you can. Okay, so we're going to move to Jupiter, and so we're going to turn off the image for a minute, but I'm going to continue to talk. So hopefully this will not take too long because the telescope doesn't have too far to move. So as we begin to get to Jupiter, we should be able to see some bands on it. Jupiter is the size of Saturn and its rings. So Jupiter appears larger. I usually prefer looking at Jupiter over that of Saturn just because it is larger. And I will go ahead and say we are glad that things are going so well tonight, but we're also testing things. This is the first time that we've used this higher magnification, and I think we're pretty pleased. Things are looking pretty good. The clouds are pretty much moving off to the side, so that's very encouraging. I've got a plane that's heading toward the moon right now. We might actually, at some point tonight, have a plane go through our field of view. So I think I can hear that John and Megan are on Jupiter. They're having to make the adjustments. Yep, that plane moved right in front of the moon, flew right in front of it. So I think we'll have Jupiter in a minute or 2 now. So I hope that someday we'll be able to have you physically back to the observatory and to look at these objects through our telescopes with the naked eye. We really enjoy having visitors and showing parts of the universe to everyone. Okay. Again, please, if you have questions, send them to me. If any of you are associated with school systems, I'm hoping that someday we can do broadcasts like this for especially 6th graders. In Georgia, 6th grade is when students learn about the Earth, and they do learn some astronomy. You can see right now that our one issue is that it's a one-way conversation. We need to figure out a way that students and teachers could communicate with us. But we're trying to expand our outreach and our opportunities. So I believe we are now on Jupiter. And wow, Megan, do we see the red spot or not?
I do not see it right now.
Okay, so we cannot see the red spot at the moment. How many bands do you see?
We can actually see some moons too.
So how many bands are you seeing?
7.
John thinks he's seeing 7 on the screen. I'd have to ask those of you in the first center, how many stripes do you see?
And then 2 moons.
Okay. So there are 2 moons to the bottom right, and those moons are Io and Europa. Io is the one that's completely covered with volcanoes. There's probably a dozen going off at the moment. And Europa is the one that has an icy surface that's probably a half mile to a mile thick that seems to be floating on an ocean. And many researchers, including several at Georgia Tech, are hoping that they might be able to find life there. Going to have to develop NASA space probes that can get there and somehow get through the ice to get down to that those layers. We've zoomed into Jupiter even more so. Now Jupiter is larger than Saturn. It's 10 times the diameter of the Earth, and its mass is 300 times that of the Earth. But it was a long way from becoming a star. It doesn't have the mass for that. Again, Jupiter spins in just 10 hours, and Jupiter and Saturn, Uranus and Neptune do not have hard surfaces. We refer to them as gas giants. It's impossible to land a space probe on Jupiter. It's like trying to land a probe on a cumulus cloud. It's just going to keep sinking. But unlike Earth or Venus, there's a solid surface underneath the clouds. Not with Jupiter, Saturn. In fact, if anything, they're more like a star. They're just going to keep going down and would eventually be crushed by the pressure, but there's no rocky surface.
Do you want to brighten up the moons?
Sure. So we're going to try to bring out some of the moons. The moons, and I said you could see this with a pair of binoculars. Galileo discovered 4 moons when he was looking at Jupiter. In fact, this was one of the observations that was key. He finally figured out that these moons were orbiting Jupiter, and hence there was something orbiting a world other than the Earth. And to the bottom right now, you can see 2 moons, and I know that they're Io and Europa, but I could not identify them more so. These 4 moons are in the same plane, and they're above the equator of Jupiter, and I see we're really zooming in on a couple of the moons. And okay, now farther out, that moon is Ganymede, and Io and Europa are the 2 closest. Ganymede is the 3rd farthest, and Ganymede is the largest moon in the solar system, and it even holds the distinction that it is larger in diameter than the planet Mercury. And then there's one more moon on the other side that's even farther away. Do you want to try to get it or not?
Yeah.
But be careful that we don't lose Jupiter. So it's up here. It's way over here, Megan. Other way. Other way. Okay, now stop and go backwards. Okay. So it's diagonally opposite from Ganymede. So yeah, go down, and it's going to be a little further out. And it's pretty far. I don't think we're going to find it, and I don't want to lose Jupiter. So let's go back. Good. Okay. These 4 moons, as I mentioned, Io is completely covered with volcanoes, and there are no craters. It's completely covered with volcanoes, and there are no craters. Europa is covered with ice. Ganymede, if you saw close-up pictures from Voyager, it looks like a couple of different colors of Play-Doh mixed together, dark regions and bright regions. And then the one we couldn't show you, Callisto, is completely covered with craters. So extreme opposites in this small family. You know, I think it might be nicer. Let's go back and see the bands on Jupiter a little bit more. It's such a beautiful view. Now, the bands on Jupiter and Saturn rotate differently than the Earth does. Someday I'm going to learn how to spin a basketball on my finger. A basketball spins the way the Earth spins. It's all solid. But Jupiter has different parts that spin at different speeds. It's more like putting cream in your coffee or tea and stirring it. And these bands, some of these are moving at different speeds, and some are actually moving backwards. Really wild, which means something on the inside is causing these to go zipping by each other. So again, a beautiful view of Jupiter. Again,
I'm slightly biased that I prefer it a little bit over Saturn, just because we also get to see the moons. So any comments from the two of you?
Oh, Jupiter is beyond my favorite planet, so
Okay.
I could look at it all day.
Yeah, Megan's saying it's her favorite planet, but I must say when we get to the moon, I could certainly look at it for a long time. So we're going to leave it here. How are we doing on time? Okay, we're doing good. Okay. And the clouds are moving further away, and we're just having a great time. What else do we need to say about Jupiter? Okay, I'll give you a little bit of trivia about Jupiter. So if you've ever gone into a Chinese restaurant and you see their calendar and they talk about the year of the dog or the year of the rat or the year of the dragon, the Chinese people have their own constellations. They looking at the same stars, but they have different designs. But those 12 years associated with this happens to do with which constellation Jupiter is in. Jupiter takes 12 years to orbit around the sun. And so for us, that tells us that a year from now, Jupiter is going to only be about 30 degrees different from where it is right now. Saturn's orbit is about 30 years, and so it's only changing about 10 degrees per year, and so it's going to be out in the fall again next year. Mars and Venus, though, they're moving a lot faster, and you really can't. It'd take me a minute to try to figure out where they would be a year from now. But on the other hand, these two are so close right now, and they are going to get closer in the sky. We are going to start losing Jupiter and Saturn. They're going to start setting in the west earlier and earlier each night. So this time in a month, they are going to be farther to the west, but they will be closer together on the sky. So there's a lot of fun you can also do just doing naked eye astronomy. We cannot see very many constellations here from our downtown site, but hopefully some of you can get out to a darker location and also get darker skies. Of course, remember the moon will change that, so you want to do the dark sky viewing when the moon is not out. So maybe one more minute on the moon. I'm sorry, one more minute on Jupiter, and then we'll go to the moon. Okay? I must say this view of Jupiter is spectacular. I don't think I've ever seen it with our equipment better than this. So, this pumps us up. We're ready to do this again, and looking forward to giving you a tour. But as I was mentioning a second ago, again, if you can talk to a science teacher or someone in a school system, and it doesn't have to be here in Atlanta. In fact, I don't know, we may have some viewers that aren't even in Georgia. There may be some outside of the country. In fact, if you are from a distance away, I would love to hear from you. Let us know where you were watching us. But it would be fantastic if we could get involved with schools and help get children and their parents interested and to see these sites. It's not that difficult, and we would love to do it. So we just need some connections. Okay, so I think we're going to go to the moon. Now, the moon, the field of view is pretty small, so I'm not certain how much of the moon we're going to see. We might be seeing just small areas, and so we'll start looking at craters. So I would say try to put it on the terminator and maybe in the center. As we're pausing for a moment, on the website, again, Google Astronomy in Georgia Tech, I have a link on the right that I believe says resources, and that is a long list of, and we're getting a loud helicopter, that is a long list of various links to various astronomical websites. I've tried to break them up, and there's a lot there for school children. But there's also some great views of a variety of things. So if you're interested, or you have children that need to be doing reports, or just want to get on and see some fantastic websites, please go to that. So it looks like we're on the moon now.
Not yet.
Not quite yet. Wow. Okay. This is a nice view, beautiful view. Megan and John surprised me. So on the left is one of the Maria. The Maria, Galileo, when he first looked at the moon with his telescope, he thought these were regions that were lakes or small seas. And Maria in Italian means ocean, sea. And they are filled in lava basins. Now, the filling in took hundreds of millions of years. And this happened after a time of heavy bombardment. So they appear rather smooth because there just haven't been that many craters there. So do you know which one it is?
So this one that we're looking at, let me come back to, so it's that crater in between these and
It's
Maria.
the one way to the right?
So it's that crater in between those two Maria.
Okay, it's flipped back and right. Is it flipped or not?
Yes, this Maria is this
That one. Okay.
This one.
So we're looking at Maria Crisium. I'm not certain what that translates as. But we can also see there is a crater, and then to the right is the beginning of another Maria. That crater, you can see how it's bright on one edge, and you can see the shadow on the other. This is the reason we like to observe during a first quarter moon. And by the way, I see a jet heading toward the moon. We'll see in a second if it flies over it. It's going to be close.
Just under.
Yeah, I think it's going to miss now. Yep, it missed. Wanted to give you that extra treat. You can also see the other craters. Again, you can see a shadow on one side and some brightness, especially the ones down to the bottom. So let's go exploring. Okay, Megan, you got the controls.
Yeah, where do we want to go?
Wherever you want to go.
Alright. Let's go up.
Okay, we're going up. Okay. Oh, okay. Stop right there. Oh, actually, no. Keep going. Let's get to this Mario. That's great. Right there is beautiful. Okay. So Megan put us on Maria. I want to kind of keep on that feature. And you can see a horseshoe-shaped crater to the upper right of the Maria. And so here's a crater that did land later on the Maria, but you see it also got partially filled in. The Maria, the filling in took, as I said, hundreds of millions of years, but some craters also got it. In fact, there's another one down below it. But most of the Maria is very, very smooth. Now, Megan, let's keep going to the right. Because, okay, so now you can also see, and go up just barely, a little bit further, there we go. So we've got craters and ridges. There's one crater that has a central mountain peak, and that's pretty unique to the moon. I realize I haven't seen too many of these in the pictures I've shown of Mercury and Mars, but we can also see some rugged cliffs along the side, and this region has a lot more craters. That's because this was not obliterated by the Maria, the lava flows filling it in. The lava flows only occurred in deep basins, so heavily cratered. Okay, Megan, go find another. Oh, that's pretty neat too. Okay, so again, lots of craters, and we're looking toward the edge of the moon, and it's because of looking at this steep angle we can see the ruggedness. Again, something we would not see during a full moon. Are seeing a little bit more, it's called seeing, as the wiggling of the atmosphere, but this is again a fantastic view. Thank you. But this is reminding you that we really are doing ground-based observations. We're not up in space. Okay. So we're going to move again. Let's go searching. Okay. So the right edge of darkness is called the Terminator, and we got a loud helicopter flying by. And I should know my lunar geography. I think that's crater Theophilus. But here's a great question. There's two craters side by side. Which one came first? Well, it's the one on the right came first because the one on the left is on top of it. It obliterated it. If the one on the right had come second, then its crater rim would be extending over into the left. Now there's another crater farther over, but we can't say which one came sooner, that one or the others. But this is another nice set, a beautiful set of a variety of craters, and it's up next to Amaria. Okay, you want to look again? Go somewhere else? Okay. So it's flipped. Okay, so we're right now in another Amaria. You saw how smooth it was. We saw the rims. Wow. So do me a favor. Okay, just stay right there. Right there. Okay, now we're down at the bottom of the moon and we're looking at the terminator. And if you notice on the far right, there are a couple of points of light. These are mountain tops that are high enough up that they're catching the light, but the bottom of the mountain isn't catching it yet. Now, as the moon continues in its orbit around the Earth, this dividing line between darkness and bright is going to be moving to the right, and in an hour or so, those will be fully illuminated. But right now, the peaks are getting a head start on catching some of the light. Yeah, there'll be more action on the right. In fact, right there's another example off to the right of catching the light. You can make out the rim of the Maria and how far it's extending into the darkness. Oh, that's a beautiful view. I don't even recognize it. Now, on the Maria, though, notice it's not completely smooth. There is rippling in the lava, but my eye is normally drawn to the smooth features more so than the cratered ones. But that's a beautiful example. There's a crater with a little crater in it, a crater next to it, some craters down below. In fact, the one to the bottom left, notice, isn't quite circular. Most craters are circular because the amount of the extent of the explosion when the meteor hits the surface. But this one was either moving a little too slow or came at a pretty steep angle. Just keep going. Just more and more fantastic views. Okay, back there.
I think we're not.
I think you're up there.
I was
Okay.
trying to get those mountains, but I think they're still
Still below. Okay. So we're looking at a map and we're trying to figure out where we are, but optics of telescopes makes images sometimes come out upside down and backwards from what we're used to. And so we're out for a nice Sunday afternoon drive. We're looking. So just stop right there for a second. Let's see. Now, there are some whiter regions. There's a crater to the bottom left, and you might notice that there's some white streaks that point toward the crater. So this is material that was ejected out, and because the moon does not have an atmosphere or any wind, the dust follows a basic trajectory, and when it gets to the surface, that's where it's staying, because there won't be any erosion. These are called rays on the moon. Okay. So, yeah, just find something you want. Okay, that's a nice view. Let's stay there for a minute. Okay. I don't have a lot to say. I mean, it's kind of neat. I see a crater inside a crater, filled in crater. There's another crater to the right, a smaller one that has a peak, and you can see there is some smoothness. We're near the edge of a Maria. Notice that we haven't been pointing out mountains. The moon does not have many geologic features, and it has none of the plate tectonics or the continents that the Earth has. So there are no mountain chains. What few mountains are on the moon are either the rims of craters, and they're technically not mountains, but they're elevated, or the central peaks in some of the craters. And there's a few mountains laying around, and they were just gigantic boulders that got thrown out by an impact and landed somewhere. And The few mountains I know of are not visible tonight. So again, we've gone to the bottom. So I'd say just go up slowly and wait. Go up some more. These are such fantastic views. Again, the smooth region is a rock known as basalt, and it's what our oceans are made out of. I always get asked if we can show or see the flags from the Apollo missions. Even with our largest telescopes, about the smallest object we could see would have a diameter of about 100 yards. So it's like a typical large building. So we cannot see any of the Apollo missions there. Oops. It's like, where to go? Hit the wrong button. It'll be right back. Or if you have to use the spotter. So we'll bring the moon back, and then we'll probably finish in a few minutes.
Did you want to do the diagram?
Well, here's the diagram, and we've been trying to indicate some of these features. I do think we found the Theophilus crater earlier, and we're back on the moon, but our field of view is pretty small, so we weren't able to show you a full view of the moon. Maybe someday we'll have 2 telescopes going and we can give you different sizes. But are we back on? So we'll leave it here for a few minutes, and yeah, there's a crater with a streak. I haven't seen that before. So, have I forgotten anything? Do I need to mention anything? Okay, so I want to thank everybody for joining us, and this tonight's viewing will be on our YouTube channel, so you can look at it or tell friends about it. Skip to the world that you wanted to see the most. We again will come back in 4 weeks. Be November 19th, and it will be some of the same objects. The moon's phase will be slightly different, so we will see some different features. And if we feel some of our testing has gone well, we might try some other fainter objects. And it also, of course, depends upon the weather. The clouds kind of prevented us from trying anything a little bit further along. But we're going to try to make these fantastic for all ages. Again, thank you for joining us. If you have any questions or comments, please email me. Again, I want to thank Megan and John for helping out. I could not do this without them. And we're just glad, though, to be coming in for you to see this event tonight. We're very passionate. We certainly enjoy showing off these celestial wonders. Thank you, and have a good night. And run outside now and look up at the sky and see all what we were showing you. Again, have a great night.